Okay, immediately, well, first of all, it's a fifth degree polynomial. If there is a rational root to this, it has to be either 1 or minus 1. But looking at the symmetry of it, I'll point out what I'm saying by this. It's 1, 2, minus 5, 5, minus 2, minus 1. And certainly, if there is a rational root, it's either 1 or minus 1. And looking at it, it sure does look like it would be 1 because everything would just cancel off. So I'm going to say x equals 1. But minus 1 wouldn't work. All right? So of the two rational roots, only one works. That means the other ones are not going to be rational. Right? They could be complex as well. So let's just write down checking 1. What do you get? You get 1 plus 2 minus 5 plus 5 minus 2 minus 1, which does equal 0, by the way. What I'd recommend you do now is just simply divide that fifth degree polynomial by x minus 1. All right? And you're dividing both sides by x minus 1. Maybe I should write that down. All right, but we've already accounted for this, though. We know that's a root. So what am I going to do over here? Divide through. And I'm going to leave it to you to divide through, and you get something like this over here. Right, that has symmetry too. But again, I mean, looking at it, you might say, oh, 1's going to work. 1 is not going to work, right? If you try 1, you get, let me write that down for you. You get 1 plus 3 minus 2 plus 3 plus 1. That doesn't work. You might say, I'll try minus 1. That would be 1 minus 3 minus 2 minus 3 plus 1. And let's see what you get there. That's not going to work either. So the roots are irrational. I should say roots are not rational. Therein lies a problem. They're not rational. So what we're going to do is, again, it's symmetry, it's even degree. What we're going to do is divide through by x squared. All right? So I put that over here for you. Again, x is definitely not 0. I know that much. So that's legitimate to do that. Then you get this over here. Then I kind of associate things together. The x squared with the 1 over x squared. The x with the 1 over x, got the multiple of 3, minus 2. All right? And then I make a substitution. The substitution I make is this one over here. All right, when we go through that substitution, I got to get that equation now in terms of y, which could be very difficult to do, by the way, but it doesn't look that bad. Like, for example, if you square both sides, what do you get? You would get y squared, x squared plus 1 over x squared. Then you get 1 plus 1, which is 2. So y squared minus 2 is equal to x squared plus 1 over x squared. Remember, I said y is equal to x plus 1 over x. Let's go back up here. What do you get? You will get y squared minus 2 plus 3 times y minus 2 equals 0. That's tough, though, right? So what do you get? Y squared plus 3y, let's see, minus 4, right? Okay. Again, with the understanding that y, the substitution made was this one over here. That's a problem, though, isn't it? I'll tell you why it's a problem. Well, I'm going to write this down now, what y is. And let's write this down. What could y be? And I'm going to say y looks like 4 and 1, right? Plus 4 minus 1. So y could be 1, or the y could be minus 4, right? But then I don't want to know what y is. I want to know what x is. Let's do one at a time. Let's do x is 1. I'm sorry, y is 1. What would that give me? 1 equals x plus 1 over x. Well, I'm getting a little bit warmer now. I'm going to multiply both sides by x. You would get x squared plus 1. This is 0. x squared minus x plus 1. I need the quadratic formula to solve that. That's going to be 2, 1, plus or minus. The b squared is 1, minus 4. So what do you get over here? X equals 1 plus or minus I root 3 over 2. So I found 2 more roots. Now let's go to the minus 4 now. So if y is minus 4, what are you going to get? Minus 4 equals x plus 1 over x. Multiply both sides by x, you get minus 4x equals x squared plus 1. And then you get 0 equals x squared plus 4x plus 1. Quadratic formula, x equals, let's see, 2 minus 4 plus or minus, we'll check the key later. You're going to get 16 minus 4, x equals minus 4 plus or minus the square root of 12, which is going to be 2 root 3s over 2, or x equals minus 2 plus or minus root 3. So I found all 5 roots. Where are the 5 roots going to be? Let's write this down. Well, if you remember in the beginning I found 1, then I just found these 2 over here, which is minus 2 minus root 3, minus 2 plus root 3. The other one I found was 1 plus or minus I root 3. And the other one was 1 minus I root 3 over 2. The reciprocal of 1 is 1. The reciprocal of this one over here, and we've done these before, is going to be this guy. And the reciprocal of this one is going to be this one. The reciprocal of this one's going to be that one, and the reciprocal of this one's going to be that one over there. The reciprocal relationships. All right, so we got what we were expecting. Was it difficult? Yeah. But I'll be honest with you, knowing the rational root theorem does help out somewhat. Certainly, I've exhausted the possibilities. On the first one, only 1 or minus 1 would have worked in the first one. 1 did work, by the way. And then the next one I did a long division. I got a 4th degree polynomial. And then I looked for something, substitution to make it easier on me. And I substituted, and I got that y substitution to make it work. All right? Are there other ways to do the problem? Of course there are. The way in which you do the problem is the way in which you do the problem. Here's the deal, though. The roots are never going to change. The roots are always going to be what we say they are. And those roots are as follows. We're going to get those 5 roots. Thank you.